Hey guys, in this lesson we would understand the trigonometric problems involving ambiguous case. Let's first understand what is meant by ambiguous case. Ambiguous case is a situation in which 0, 1 or 2 triangles can be drawn when we are given the information in a problem, and ambiguous case occurs when we are given an SSA triangle. Now what is meant by this SSA triangle? It is any oblique triangle for which two sides are given and the angle opposite to one of the given two sides is given. So we are given side 1, side 2, and either we are given this angle or we are given this angle. However, we should not be given the angle in between the two given sides. Then that situation is called SSA triangle, and we have learned in the previous lesson that in SSA triangle we apply SIne law. Therefore, ambiguous case is linked with SIne law of trigonometry. Let's go over different situations of ambiguous case. Ambiguous case can be seen in both obtuse or acute triangle. So if we have an acute triangle, that means all the angles of the triangle are acute. Let's say the triangle is triangle A, B and C. So the side that is opposite to angle A is side A, side that is opposite to angle B is side B. Let's say we are given side B, we are given side A, and we are given angle A. Then the situation we are in is called SSA triangle. Whenever we are given an acute triangle that has SSA situation, the first thing that we have to do is find the perpendicular height of the triangle. This perpendicular height is going to be drawn from the third vertex and is going to be called as h. Now how do we find out the value of h is? We know h is the perpendicular, so this triangle is a right triangle. Now we already know the side B and angle A. Therefore, to find out the value of h, we can apply sine ratio because this is a right triangle. So we can say sine A is equal to opposite over hypotenuse. Opposite is h, hypotenuse is b. The h value would be equal to b times sine angle A. Once we get the value of h, so we would now also know h. Apart from knowing the values of side B, side A and angle A, now comes 4 cases to consider. Case 1 is if side A value is less than side H value, then the conclusion is no triangle exists. That means we cannot solve the question as we cannot draw a triangle. No triangle also means 0 triangle exists. Case 2 exists if we get the height value equal to the value of A. So if A is equal to H, then one triangle exists. So we would get only one solution for that particular question. Next case is case 3. Here one thing that is important to note is the side that we are comparing H with is the side opposite to which the angle is given. So case 3 is if side A is greater than side B. So here we do not have to worry about what is the length of H. All we have to worry about is that this side A is greater than side B, and in this situation one triangle would exist. Case 4, that is the last case. If in case side A is greater than side H but smaller than side B, how do we write that down is if side A is greater than side H and smaller than side B, that means the value of side length A lies in between the value of side length H and B. Then in that particular situation, 2 triangles would exist. And when 2 triangles would exist, if we are given a word problem, we would have 2 answers to the given problem. These are the 4 cases for an acute triangle that has SSA situation. We can either have 0, 1 or 2 triangles existing in such a case, and depending upon the number of triangles we would get the number of solutions. Next type of ambiguous case is seen when we have an obtuse triangle. We know obtuse triangle is the triangle where angle is going to be greater than 90. So since here we considered angle A given, definitely this angle A would be equal to acute angle because this is acute triangle ambiguous case. For obtuse triangle, angle A would be obtuse angle. And if there is an obtuse triangle with angle A, it would look like this: A, B, and C. In such a case, we do not have to find out any height. It is still SSA situation because ambiguous case only exists in SSA situation of a triangle. So we would be given side A, we would be given side B, and we would be given angle A, that is an obtuse angle. The two cases that would result in this case is if we are given the side A value less than side B value, or if side A is equal to side B, then there will be no triangle existing in such a case and there will be no solution to the given problem. However, if side A is greater than side B, then in that case there will be one triangle existing in obtuse triangle SSA situation. So we would have one answer or one solution to the given problem. Let's understand this ambiguous case with an example. Let's say we are given sides A equal to 5 cm, side B equal to, side C equal to 8.5 cm, and angle A is given to us as 36 degrees. So first thing that we have to look at is the angle that is given to us. Since this is an acute angle, so we would follow acute angle or acute triangle ambiguous case situation. Let's make this kind of a triangle. This is side A. We are given, this is angle A. We are given side C and side A. So let's put C here and let's put B here. Side A is given to us as 5 cm. Side C is given to us as 8.5 cm. And angle A is given to us as 36 degrees. Now, whenever we are in an acute triangle situation, our first step is to find out the height. So we would find this height using h equal to 8.5 sine 36, because this is going to be a right angle triangle and we're just applying sine ratios. We know sine 36 is opposite over hypotenuse, so that would be h over 8.5. When we solve for h, we get 8.5 times sine 36, and this value is equal to 4.996. So now we have side A equal to 5 cm, side C equal to 8.5 cm, and side H equal to 4.996 cm, which is approximately 5 cm. However, it is smaller than 5. So going back to the acute triangle cases, we notice here that the A value and H value is almost similar. Therefore, we always have to remember that whatever sides we are comparing, they should look alike. So this is a whole number side, whereas this is a 3 decimal place side. So we would change it, or we would round this to the nearest whole number, and that would give us 5 cm itself. And now when we consider the 4 cases, we notice that our question matches case 2, where side A is equal to side H. Hence we conclude that in this particular question, one triangle exists. And this is how we figure out how many number of triangles would exist in an acute or an obtuse triangle in SSA situation. Let's take up an example of a word problem. So the question says, A and B are part of a team studying thunderclouds. The team is about to launch a weather balloon. A's rope is 7.8 meters long and makes an angle of 36 degrees with the ground. B's rope is 5.9 meters long. Determine the distance between A and B. So let's say, because the angle is 36 degrees, so this is an acute triangle. Let's say this is where A is standing, and let's say this is where B is standing, and this is where the balloon is that they're launching. The length of A's rope is 7.8 meters, whereas the length of B's rope is 5.9 meters. The angle made by A's rope with the ground, so this is ground, is 36 degrees. Now because we are given SSA situation, as we know, 2 sides adjacent to each other and an angle that is opposite to one of the sides, so we have to first determine how many triangles can be drawn for this particular question. And how do we determine that is that we first find out the height here. height is 7.8 times sine 36. When we put this on the calculator, we get 4.58. Because these two sides are given to us in 1 decimal place or up to 10th place, so we would round this also up to 10th place, so that is 4.6 meters. Now when we compare all the sides, side A is 5.9 meters and side B is 7.8 meters, and we notice that the side A value lies in between side H and side B. So this is a case in which two triangles exist, where one of the triangles would be what we have already drawn. And when we have to draw the second type of triangle in an ambiguous case situation, what we do is we put the 2 points A and B on the same side of the vertical height instead of placing on the opposite sides. So this is how the vertical height would look like in this case. This is 7.8 meters. This is 5.9 meters, and this is where the balloon is. Angle A is given to us as 36 degrees. The question wants us to find the distance between A and B. So in order to find out the distance between A and B, what we have to do is, in the first triangle, to find this side, we can use SIne Law. So when we use SIne Law for the first triangle, we can find out this angle. To find out the value of angle, we would write down sine 36 divided by 5.9 equal to sine B divided by 7.8. So sine B would be equal to sine 36 divided by 5.9 multiplied by 7.8. That would give us sine B equal to 0.777. As we are looking for angle B, we would take the sign on the other side, so it becomes sine inverse of 0.777, and that would give us angle B equal to 50.99 or 51 degrees. Therefore, we got this angle equal to 51 degrees. Now we can use both of these angles, add them up and subtract it from 180 to get this angle. Once we know the angle in between the two sides, we can use cosine law to get this opposite side. So the angle that we get here is 93 degrees. Now we would be using this angle because now we have SAS rule. We would be using this rule to find out this side using cosine law. Let's call this unknown side as x. So x would be equal to square root of 7.8 square plus 5.9 square minus 2 times 7.8 times 5.9 times cosine 93. When we put this all on the calculator, we would get this value. And then finally we get is 11.98 meters. Or if we round it to the nearest whole number, that would be 12 meters. So in first case, the distance between A and B is 12 meters. As we have two cases in this particular question, so we would have two solutions. Now let's see how to solve case number 2. In case number 2 also, we would follow the same steps to get this angle. So we would be doing sine 36 over 5.9 is equal to sine angle B over 7.8. However, we notice here that this angle is not an acute angle. Like here, the angle that we got was 51 degrees. So 51 degrees would not be this part of the angle, but it would be this part of the angle. So in order to get this angle, we would have to do 180 degrees minus 51 degrees, and that would give us 129 degrees. So this angle is 129 degrees. Now to find out this angle, we would be adding 36 and 129 degrees, and we would get a 15 degree angle here. Now to solve for side AB, when we apply cosine law, the angle that we would be taking is 15 degrees. So side AB, let's call this side Y, would be equal to square root of 7.8 square plus 5.9 square minus 2 times 7.8 times 5.9 times cosine 15 degrees. And this would give us 95.65 minus 88.9. That would give us a value of square root 6.75, which is equal to 2.5. 2.598, or if we round it, we would get 2.6 meters. Therefore, the y value here is 2.6 meters. And we can conclude from here that A and B could be either 12 meters or 2.6 meters apart. And this is how we solve a problem involving ambiguous case.